So today we're going to continue with 10.4, and our focus is going to be on laws of logarithms. So let's quickly go over what the laws of logarithms are. Up until now we've studied the properties of logarithms, so now we're going to look at the laws. One says that log base b, so that's any base, of m times n, where those are positive numbers, is equal to log base b of m plus log base b of n. So essentially it's saying that if you have two terms being multiplied together as the argument of the base, you can then split them up as the log of that base of one of them plus log of that base of the second one. And that applies for multiple different logs. So if you have log base b of x, y, z, this would be log base b of x plus log base b of y plus log base b of z. Okay. For number 2, we've got log base b of m divided by n, and by laws of logarithms, that is equal to log base b of m minus log base b of n. Okay. So if we do another example, log base b of x times y over z, this is log base b of xy minus log base b of z. We can't leave that as is though, so we're going to get log base b of x plus log base b of y minus log base b of z. And finally, the third one is that log base b of m times k is equal to k times log base b of m. So essentially if you've got something to a power, as you do here, that power can then come down in front of the log and be multiplied to the log. Okay? So let's look at some examples. In number 2, it says log base 2 of m times n quantity to the fourth power. Okay. So the first thing I'm going to do is I'm going to distribute that fourth power. Okay, and then use the first law of logarithms to split up our log and expand it into log base 2 of m to the fourth plus log base 2 of n to the fourth. And then, using the third law, I can bring those exponents down. So I got 4 times log base 2 of m plus 4 times log base 2 of n. Now let's look at 8. 8 says log base 2 of 1 over m times n. So I'm going to use the second law of logs to split this up into log base 2 of 1 minus log base 2 of m times n. Log base 2 of 1 is just 0, right? Because log of base anything of 1 is 0. So we've got 0 minus log base 2 of m plus log base 2 of n using the first law of logs. And then I distribute the negative. Now let's look at some different examples. For, I believe it's like 9 through 18, I want to say. Or maybe it's at 21, or I think it's through 20. We are going to be using solely the fact that log base 10 of 9 is 0.95 and log base 10 of 2 is 0.30, okay? And so essentially we're going to be looking at a whole bunch of different logs, and we want to simplify and evaluate them using those two facts. So essentially we're going to get every single one into some sort of form that allows us to use those two facts. So let's go ahead and look at 12. In 12, it says log base 10 of 3, and we need to find the value of this. So this doesn't look anything like 9. It doesn't look anything like 2. So you're probably wondering, well, how the hell is this going to work? What we're going to do instead is we're going to start off by the fact that log base 10 of 9 is equal to 0.95. Okay, and we know that 9 is equal to 3 squared. So we're going to plug that in. So we have log base 10 of 3 squared is equal to 0.95. Using the third law of logs, I'm going to bring that exponent down. So I've got 2 times log base 10 of 3 is equal to 0.95. And then I'm going to divide both sides by 2 so that I get log base 10 of 3 is equal to 0.95 divided by 2, which is equal to 0.475. We want to round to the two decimal places, so this is approximately 0.48. And we've solved it. For 18, we want to find the value of log base 10 of 1 over 2,000. So we're going to use the second law of logs to split up our log into log base 10 of 1 minus log base 10 of 2,000. 2,000 is equal to 2 times 1,000. And 1,000 is the same thing as 10 cubed. So log base 10 of 1 is 0 minus log base 10 of 2 times 10 cubed. So using the first law of logs, I'm going to split up our second logarithm into log base 10 of 2 plus log base 10 of 10 cubed. I'm going to use the third law of logs to bring that power down. Log base 10 of 10 is just 1 by properties of logs. And log base 10 of 2 by the facts given at the beginning is 0.30 plus 3 is equal to negative 3.30. Let's look at some other ones then. For these ones, we want to now put everything into one logarithm instead of putting everything into two separate or multiple logarithms. So what we're doing here is we are rewriting as a single logarithm. What we did before was expanding into multiple logarithms. So for 22, we've got log base 10 of x minus 4 times log base 10 of y. So first thing I'm going to do is use the third law of exponents to bring up that 4 to make it log base 10 of y to the fourth. Then I'm going to use the second law of logarithms to combine to get log base 10 of x divided by y to the fourth. Let's look at one a little more complicated. In 26, we have log base 5 of x minus log base 5 of y plus 2. Now this 2 at the end may throw you off at the beginning, but remember it's 2 times an implied 1, right? Because there's always an implied 1. So remember that 1 is equal to log base b of b, where b could be any positive number. So let's say since we have log base 5, we're going to do log base 5 of 5 is equal to 1. So we're going to use that fact and plug it in for the 1 next to 2. So you get log base 5 of x minus log base 5 of y plus 2 times log base 5 of 5. From here, I'm going to use the third law of exponents to bring up that 2 in the third logarithm here to make it log base 5 of 5 squared. And then from here, I'm going to put everything that has addition closer to our first term. So this is going to be log base 5 of x plus log base 5 of 25 minus log base 5 of y. And then I'm going to combine. So this is going to be log base 5 of 25x minus log base 5 of y equals log base 5 of 25x over y. Okay, let's keep going with the simplification. So we're going to look at 32, which says log base 4 of 3 minus log base 4 of 48. Okay, so we want to try and simplify as far as we can without using a calculator. And so I noticed that 48 can be broken down into multiple numbers, right? 48 for 1 can be 3 times 16. And 16 is 4 times 4. So that'll allow me to simplify. Plus, if I have something with an argument 3, I can potentially cancel it out with this first logarithm that also has argument 3. So this is going to break up into log base 4 of 3 minus log base 4 of 3 times 16, which is going to be log base 4 of 3 minus parentheses log base 4 of 3 plus log base 4 of 4 squared. Okay. Third law of logs, I'm going to bring down that 2 in the third logarithm here. Okay, and then I'm going to distribute the negative. So I've got log base 4 of 3 minus log base 4 of 3 minus 2 log base 4 of 4. The log base 4 of 3's will cancel out, and log base 4 of 4 is just 1, so I get negative 2 times 1, which is negative 2. Now let's look at ones where we have to solve for x. Okay, so in this one, we've got log base b of x squared plus 7 is equal to 2/3 log base b of 64. Now recall that if we can get two logarithms with the same base and different arguments equal to each other, we can just set the arguments equal to each other. So what I'm first going to do is use law of logs to bring up that 2/3 to an exponent on the right side. And now I'm going to take x squared plus 7 and set it equal to 64 to the 2/3 because the base of the logs are the same. So I get x squared plus 7 is equal to the cube root of 64 squared, which is just 4 squared, so this is 16. So I've got x squared plus 7 is equal to 16. Subtract 7 from each side and take the square root. Now, because we want to make sure we're not taking the logarithm of a negative number, just double check with a quick mental check. If I plugged in negative 3, I'd end up with a positive value because anything squared is positive, so we're good. Let's look at 38. 38 says log base a of 3x plus 4 minus log base a of x minus 5 is equal to log base a of 8. Now, before we can set the arguments equal to each other, we've got to get two logs, one on the left side and one on the right. So I'm going to use the second law of logs to combine what's on the left side to become log base a of 3x plus 5 over x minus 5 is equal to log base a of 8. Now that I have one log on the left and one log on the right with the same base, I'm going to then set the arguments equal to each other. I'm going to multiply both sides by x minus 5. So I get that 3x plus 5 is equal to 8x minus 40. I'm going to add 40 to each side and subtract 3x. I get 45 is equal to 5x. X is equal to 9, which with a quick mental check does work in our equations here. Okay, now let's look at 40. 40 says log base 3 of x plus 2 plus log base 3 of 6 is equal to 3. So I'm going to use first law of logs to combine the two logarithms on the right side. I'm on the left side. And then I'm going to rewrite this into exponential form. So I've got 3 cubed is equal to 6x plus 12. 3 cubed is actually just 27. I'm going to subtract 12 from each side. And I get that 15 is equal to 6x. So x is equal to 15 over 6, which is 5/2. Now let's look at 42. 42, we're looking at combinations. So, or compositions, sorry. If f of x is equal to 3 to the x and g of x is equal to log base 9 of x, find a f of negative 1. So we'll start there. First, we're going to find f of negative 1, which is 3 to the negative 1, so this is 1/3. Then we're going to find f of 1/3, which is 3 to the 1/3 power, so this is the cube root of 3. Okay, now let's look at b. We want to find g of 81. So first we're going to find g of 1 over 81, which is going to be log base 9 of 1 over 81. I don't want to leave this like this. I want to simplify though, so I'm going to use second law of logs to break this up into log base 9 of 1 minus log base 9 of 81. Log base anything of 1 is 0. So this first log is going to go to 0. And then log base 9 of 81. Now remember that 81 is equal to 9 squared. So this is going to be negative log base 9 of 9 squared, which is just negative 2 log base 9 of 9, which is just negative 2. I'm going to then take that and plug it into g of negative 2, because that's what I'm originally solving for. And that's going to give me log base 9 of negative 2, which is not possible because we cannot take the log of a negative number. Okay. And lastly, C, we want to find F inverse of G of 9. So first thing, remember that F inverse of x has to be the inverse of f, which is 3 to the x. And remember that exponential functions, their inverse is logarithms. So f inverse of 3x is just 3 to the x is just log base 3 of x. So that's what we're going to use. So first we're going to find g of 9, which is log base 9 of 9, which is 1. And then we're going to find f inverse of 1, which is log base 3 of 1, which is just 0. And that's our answer. Now let's look at 46. We are still solving for x. This time the equation is log base 2 of log base 4 of x is equal to 1. So we're going to rewrite the first log in exponential form. So this is 2 to the power of 1 is equal to log base 4 of x. So this just means that log base 4 of x is equal to 2. We're going to again rewrite in exponential form. So we've got 4 squared is equal to x. So x is equal to 16. And there's our answer. For the last one, we're going to look at 50. 50 says 2 times log base 3 of x minus log base 3 of x minus 2 is equal to 2. So I'm going to use the third law of logs to bring that 2 up in the first logarithm. So I get log base 3 of x squared minus log base 3 of x minus 2 is equal to 2. I'm going to use the second law of logs to combine into x squared over x minus 2 is equal to 2. And then I'm going to rewrite this into exponential form. So we've got that 9 is equal to x squared over x minus 2. Multiply both sides by x minus 2. I get 9x minus 18 is equal to x squared. 0 is equal to x squared minus 9x plus 18. This factors into x minus 3, x minus 6, so x is equal to 6 or 3. Do a quick mental check. 6 and 3 both work in the original, and so those are my answers. So the classwork due Thursday for F block and Friday for C block is page 476, numbers 1 through 41 odd, and 45 through 51 odd. If you look at the note packet I gave you, just a quick reminder, your next test will be the next Thursday and Friday. That will be the 23rd and 24th of March.